Okay, so let's get started and solve problem 1 from the exam. So in this problem, we have a stack gas that's containing 35,000 micrograms per meter. So what I like to do is just pick out all of the important information and put it on the side here. So we're going to write that we have a concentration of 35,000 micrograms per cubic meter of particulate matter. It's flowing out of a 3-meter diameter stack. So we have a diameter here of 3 meters. And velocity, and so keep in mind, this is sort of like a stack like this. And we have this diameter here. And we have a velocity of this gas that's coming out. And so this velocity, we're told, is 1,500 meters per minute. Stack gas has temperature of 190 degrees Celsius and a pressure of 1 atmosphere. Okay, and so then we're asked to determine the mass emissions rate of particulate matter in kilograms per day. So recall that our mass emissions can be written like so: C times our flow rate, so our concentration, mass concentration times our flow rate. And in this case, we can redefine Q as V times A, so we can replace that, and we have our velocity times our area, so that's the area right here. And we can further break that down to relate that to our diameter of our stack by replacing area with pi d squared over 4. Now we have it in terms of our diameter here. And we can go ahead and plug in some numbers here. So we have 35,000 micrograms per cubic meter times 1,500 meters per minute times pi times 3 meters squared divided by 4. And if we do that math, we should get about 371,100,632 micrograms per minute. And of course, we're trying to get into kilograms per day. So we're going to multiply by 1 gram per 10 to the 6 micrograms and 1 kilogram per 1,000 grams. And then we're going to multiply also, so second row here, by 60 minutes per hour by 24 hours per 1 day. And if we do all of those conversions, we should end up with a mass rate of 534.4 kilograms per day as our answer for part A. Okay, so part B, we're determining the concentration of particulate matter in micrograms per dry standard cubic meters. We're assuming standard conditions are at 20 degrees Celsius and 1 atmosphere, and we're not given a percentage of our water vapor. So in that case, we should assume we're already in dry conditions, but we need to convert to standard cubic meters. So here we can look at 2 different points. So our first point being the actual concentration, the actual conditions. So that's at 190 degrees Celsius and 1 atmosphere. And then if we're converting to standard temperature, we're trying to convert to 20 degrees C and a P2 of 1 atmosphere. So also recall that our concentration is our mass divided by our volume. And in this case, our concentration is at actual conditions is 35,000 micrograms per cubic meter. And so what that means is that in 1 cubic meter, we would expect to have 35,000 micrograms of particulate matter. So let's take this 1 cubic meter basis and convert that based on the change in temperature from 190 to 20 degrees Celsius. So to do that, we're going to use this relationship here. T1 P1 over V1 equals T2 P2 over V2. And in this case, we can rearrange this to say our V2 is equal to our T2 times our P2 times our V1, all of that divided by our T1 and our P1. Now, the other thing is we want to get these temperatures in terms of Kelvin. So in this case, we're going to convert from 190 degrees Celsius into 463 degrees Kelvin. For 2, we're going to convert from 20 degrees C into 293 degrees Kelvin. And so when we put our relationships in here, we find that our volume of that 1 cubic meter would be 293.15 K times 1 atmosphere times 1 cubic meter, all of that, divided by 463.15 K times 1 atmosphere. And here we should get 0.633 cubic meters. And so our concentration now is 35,000 micrograms. We still have the same amount of particulate matter, or mass, in that volume, but the volume has changed. It's gone from 1 cubic meter to 0.633 cubic meters. So we can put this on our bottom here and calculate that, and we should get a concentration of 55,297 micrograms per cubic meter, and that's under the dry standard cubic meter conditions.